Here's another thick lens practice problem video walkthrough, diddly doodad. I just threw this together and I haven't pre-solved it. And so if there's any problems or if I make a mistake and I backtrack, I'm sorry. But go ahead and you can look at it, try to solve it on your own, and see if you can solve these questions. And then we can walk through it together. But we've got a thick lens here with a front surface power of plus 30, back surface power plus 10, index refraction inside the lens is 1.5, and the distance between the two lenses is 0.05. Or excuse me, the distance between the two surfaces, so how thick the lens is. The object is negative 0.05 meters away. Yeah, so go ahead and try solving it. But anyways, so I'm going to jump right into it. What we're going to do first is find the divergence right before the front surface. So this is right here before it's refracted by the front surface power. So we're going to use the equation n over distance equals the divergence. And so that would be a negative a1 divided by a negative 0.05. And that will give us a math I can't do in my brain right now because I'm tired. It's a negative 20. And because it's negative 20, that's diverging light, right? So negative 20 diopters. Erase that. Sweet. So that gives us divergence right here. Okay. Now we need to find the divergence right after the front surface. And so we're going to use the equation that's basically divergence of object plus surface power gives us the divergence of the image. And so I'll take that negative 20 and I'm going to add that to the front surface power, which is a plus 30. And that will give us a positive 10 diopters. Sweet. That's simple as that. So that will be the divergence right here. Now we need to find the divergence right before the back surface of the lens. And so one thing, we can't just jump right to it and be like, oh, it's negative 10, isn't it? Or positive 10. We have to remember that divergence is a factor of distance. So as the distance changes, so does the divergence of the light. And when we measure divergence, it's always from a point, whether that's the focal point where light is focusing in or the point source of light where light is diverging from. We have to always measure from that point. So in order to find, let's do orange, to find that divergence right here, we need to find a point of reference so that we can measure from it. And so we'll use the divergence from the right here, right after the front surface, to find that point. Sorry, that was a lot of saying the word point. So what we'll do is we're going to find that focal point for the divergence, which is plus 10. And so we'll do 1.5, because we're inside the lens material now, divided by plus 10. Hopefully it works. That gives us a 0.15. Okay, so from the back surface of the, from right after the front surface, I'm having a brain fart. Anyways, it's 0.15 from that yellow surface that I marked. So from here, and then 1.5, we'll just put it out here. Sweet. Sorry about that. So then the light will travel 0.05 meters. And so we need to do, we have 0.15 minus a 0.05. And that will give us a 0.1. And then we'll use that to find the divergence right before the back surface. So we'll do 1.5, because we're still inside the lens material, divided by 0.1. 1.5 divided by 0.1. 15. Let me just make sure that's right in my brain. So we do that, 1, 1.5 divided by that, and we get this power. Yep, 15, that feels right. So that's going to be a positive 15 diopters. Great. Now to find the divergence right after the back surface, we just have to add those two together. So let's do a different color, we'll do purple. Plus 15 diopters, and then we add that to the back surface power, which is 10, and that will give us a 25. Great. And so that's the image, that's the divergence right after the back surface right here. And then to find the image location, we have to use that divergence right after the back surface to do it. So, well, since we're now in air, I'm going to do 1 divided by 25. And that should give us a number that I don't want to do in my head, 0.04 meters away. So it will come out to be somewhere like, I don't know, here for the image location. So anyways, so you can work through that. And if you want to do this last part, I'm not going to do it right now because I don't want to. But basically, if you wanted to find the image location, if it didn't have that same thickness, you would just add this and this together to get the total power of what would be a thin lens, and then just find the image location of that. So if you'd like. So anyways, that's how you do the stick lens problem. Sorry, I just cruised through it real quick. But anyways,